Hey there, Kipsters. Mr. Piazza here. We're looking at objectives 3B.7 through 9. That's all about slope-intercept form, a really special way to write the equation of a line. I've broken this down into 3 skills, which you'll see over the next 3 slides. The very first is just identifying what the slope and the y-intercept is when I give you an equation. So I'm going to do 3 examples, and I'm going to ask you to do 3 if I give you an equation in slope-intercept form. To be clear, when we say slope-intercept form, we mean an equation that's in the form of y equals m times x plus b. And the reason it's called slope-intercept form is because m, the coefficient of x, is the slope. And b, the constant that's all by itself, is the y-intercept. And those 2 pieces of information are going to be enough to graph these lines later. So, starting with A, I'm going to identify the slope and the y-intercept for each of these equations. Looking at A, I see y equals negative 2x plus 3. I can see that the coefficient of x is negative 2. So that means the slope is negative 2. And if I were to graph it, it might be helpful to know that it's the same as negative 2 over 1. I see that the constant is 3. So B, our y-intercept, is going to be 3, and that's where I'm going to start the graph. I have my slope, I have my y-intercept. Now, looking at B, y equals x minus 4. I don't see the coefficient this time, so I know that there's actually a secret coefficient, which is a 1, and our slope for this equation is 1, which is the same thing as 1 over 1. Then, my y-intercept, it looks like it might be positive 4, but if I really kill subtraction, I can see that the y-intercept is negative 4. And so B is negative 4. I have my slope, I have my y-intercept, and later that'll be enough to graph this equation. Last one I'm going to do is C. Looking at it, I can see pretty clearly that the coefficient of y equals 1/2 x is 1/2. So the slope is 1 over 2. I do not see a constant though, and so that's where I need to use my knowledge to know that it's not plus 1, but it is plus 0 that I don't really see, because if I add 0, it doesn't change it. So the constant and the y-intercept is really 0, which means it's going to start at the origin. At this point, I've done 3 examples. I'd like you to stop the video here, try D and E, and press play after you have identified the slope and the y-intercept for both of those equations. Okay, you tried D, now it's time to check. Y equals negative 2/3 x minus 1. The slope, you should have said, was negative 2/3, so m equals negative 2 over 3. And the y-intercept, after you killed subtraction, is negative 1, so B there is negative 1. I hope you got those right. Looking at E, the slope, which is the coefficient of x, hopefully you can see is 6, so that means the slope is 6 or 6 over 1. And the y-intercept is just positive 1. B equals positive 1. So at this point, we've reviewed how you find the slope and the y-intercept when looking at an equation in this form, in slope-intercept form. But the reason we do that is so that you can graph it. And so now we're going to look at equations so that we can take that equation and graph them using slope-intercept form. So starting with A, my very first step, just like last time, is to identify the slope and the y-intercept, and then I'll be able to graph them. So I'm going to complete these first 3 examples, and I'm going to ask you to complete the last 2. Looking at this first equation, I can see that the slope is negative 4, which is the same thing as negative 4 over 1, and the y-intercept is 3. And the reason that information is valuable is because if I have my x-axis here and my y-axis here, I'm going to start with my y-intercept of 3, which is right here. I've used my y-intercept. And now I want to build a line with a slope of negative 4 over 1, which means the rise is down 4, or negative 4, 1, 2, 3, 4, and a run of 1. And that's where my second point goes. I could do it again, down 4, and over 1. And if I connect those, this is line A. Another example I'll do in green, B, which says y equals 2x minus 3. Again, my first step is to identify the slope, which I can see is 2 over 1. And my y-intercept, which, after I kill subtraction, is the same thing as negative 3. So again, I'm going to start with my y-intercept, which this time is negative 3, which is right there. And now I need to build a line with a slope of 2 over 1, which means starting here, I have a rise of 2, 1, 2, and a run of 1, 1. There's my first point. I could do it again, a rise of 1, a rise of 2, and then a run of 1. There's my second point, a rise of 2, a run of 1. There's my third point. And if I connect those, that is line B. Last one I'm going to show you, C, y equals 2/3 x. First step again is to identify the slope and the y-intercept. The slope is 2/3. The y-intercept you don't see. So you need to know that it's really plus 0, and the y-intercept is 0. So starting with my y-intercept, that means I start at the origin, since the y-intercept is 0. And then I need to build a line with a slope of 2/3. That means a rise of 2. Whoops, I did a rise of 3. A rise of 2, and a run of 3. There's my second point. A rise of 2, a run of 3. There's my third point. If I connect those, I have my line C. Okay, I've showed you 3 examples, so now I'd like you to try. Please find the slope and y-intercept for D and E, and then graph them. You can just sketch these on your paper, and then compare them to what I do after you play the video. So press stop here until you've graphed both of these equations. Okay, you've tried them, so now it's time to check. Looking at D, the slope is 1/2, and the y-intercept is 1. So if you graph that, that means your y-axis is here. You should have started at 1 above the x-axis, that's the y-intercept, and built a line with a rise of 1 and a run of 2. Rise of 1, run of 2. And that should have been line D. Next, y equals 3x minus 5. That means your slope was 3, which is the same thing as 3 over 1. And your y-intercept was, after you kill subtraction, negative 5. You need to start at negative 5, your y-intercept, that's right here. And build a line with a slope of 3 over 1. 1, 2, 3 over 1. There's your second point. 1, 2, 3 over 1. There's your third point. And connect them. And that should have been your line E. So again, the key here is to identify the slope and the y-intercept, just like we did in slide 1. And then from there, you put a dot where the y-intercept was, so that was our second step, to always put that dot where the y-intercept was. And then last, we built a line with the slope that we identified. So it's definitely a lot of skills here, combining into graphing a single line. Okay, the last step here is how do you write the equations of these lines? I'm going to stop here.